Moving on to item 8 in the agenda, we're going to get a presentation on innovative nutrient reduction projects for improving water quality from Mr. Stephen Suau. The purpose is to inform the committee on current and ongoing research and recent projects funded by grants under Florida's Innovative Technology Program on the application of passive nutrient reduction systems. The connection to our CCMP is that this relates to water quality priority action number 3, to reduce urban stormwater and agricultural runoff pollution. I'd like to now welcome Mr. Stephen Suau and turn this over to him. And as I mentioned during the break, this was a very engaging presentation with lots of discussion in the management committee meeting. So I look forward to this now, and I'm glad that we're where we're at in the agenda to allow plenty of discussion after the presentation. So with that, thank you.
Thank you. And thanks, Jennifer and the NEP for asking me to come. I want to just, by way of background, my name is Steve Suau. I have worked in water management in Southwest Florida for about 40 years. Some in the public sector. I served as director of Sarasota County Stormwater Program and executive director of planning and development services for a short period of time. But most of my career has been in the private sector. I sold my company about 2 years ago, and have more time to kind of just work on projects that like these that I enjoy doing. That are more unique to me and some clients that I still work with. So I'm going to present a little bit of policy and science for context for these types of technologies. And then I'm going to talk a little bit about the applications for nitrogen removal, specifically nitrate, and a little bit about phosphorus removal with something called carbon biochar, some people call it. So from a context standpoint, as many of you know from policy in the state adopted numeric nutrient criteria for phosphorus and nitrogen several years ago in coordination, shall we say, with EPA. And that criteria does acknowledge the diversity of hydrogeology in the state of Florida. So there's different regions and there's different criteria depending on where you are. Specifically, the northern portion of Charlotte Harbor, basically north of the Caloosahatchee, is in the west central region, and the remainder to the south is in the peninsular region. And the main difference there is the concentration allowed for phosphorus. It's naturally occurring in a much higher concentration in the almost double, or I'm sorry, 4 times as much in the west central region. And talk a little bit about that. But the other takeaway here is that the original narrative criteria that was fine-tuned with the numbers still survived. And I think that criteria is important because it basically ties the management of nutrients to maintaining the natural population of aquatic flora and fauna biology. That's the real litmus test of to have healthy biology. Nutrients are an indicator or surrogate for that. Am I able to move the screen?
That's me,
Okay,
right?
go ahead. So just really quick on phosphorus, I mentioned is in this region, the phosphorus is concentrations allowed or higher. It's because it's so prevalent in the Gulf Valley. The Department, I think, of the Interior did studies back in the 1940s to locate it. That's why it's being mined, because it's prevalent. But as a result, you don't really need phosphorus in the fertilizer in that region. And I would say that from my experience, the golf course industry is pretty much in tune to that in the region. They don't use phosphorus typically in fertilizer. And that's one good reason why it might be good to have unique criteria for fertilizer application based upon some of the same regions that we have numeric nutrient criteria for. Next. Nitrogen is the nutrient that I want to spend the most time on. And to do that, just to explain a little bit of the science. So nitrogen is like water in some ways, in that it can exist as a solid, liquid, or gas. And there's also a natural nitrogen cycle like the natural hydrologic cycle that brings that nitrogen from the atmosphere into the soil, into plants, and eventually goes back into the atmosphere naturally. This is how it's worked for eons, mainly through biology. There are bacteria that can fix nitrogen or pull it from the atmosphere. There is other bacteria in soil and water that can convert that ammonium nitrogen to nitrate. And there's other types of bacteria called denitrification bacteria. And these are the real, in my view, the real bacteria that cause the magic is they convert it and put it back in the atmosphere through denitrification and back into the gas form. 78% of what you breathe is nitrogen. It's the most common element in the atmosphere, but it's extremely stable. It's very hard to pull out. This bacteria is able to do it. Next slide. Until about World War I, the German chemist Haber-Bosch figured out how to extract and make synthetic fertilizer. That really started what they called the Green Revolution in terms of being able to grow food without really managing the soil. That was an unintended consequence. You could just apply reactive nitrogen through fertilizer and grow things that way. Next. So as a result of that, we have a lot more nitrogen that's gotten into our soils and water, and it's become a real problem for waterways in terms of algae growth and whatnot. So to talk about some of these projects, I wanted to also kind of put into context the cost benefit and the return on investment idea. The Southwest Florida Water Management District has got criteria that they typically use for evaluating projects that come in for grants that is based upon the cost for nitrogen removed or for nitrogen removal. This criteria has evolved over time. It's, in my opinion, it's really well thought out, and it does continue to evolve. And the two things here that are critical, I think, is that to get the highest number of points, you're looking at a cost of less than $150 per pound of nitrogen removed. And you're looking at the project being able to remove 1,000 pounds per year. The $150, as I understand it, is based upon a 20-year life cycle. Okay, so and the 1,000 pounds per year is an annual number. Okay, so I kind of think this is a really good guideline to use, and we'll reference this as I move through these projects. The first application. One more thing. Go on to the next slide. Thanks. So one of the things I wanted to mention is to get rid of nitrate. Nitrate in particular can be soluble. It is the outcome of septic tanks typically. It's the outcome of wastewater treatment plants that do not need advanced wastewater treatment. That's essentially what AWT or advanced wastewater treatment plants are doing, is they're adding a denitrification component to get the nitrate out. If it does not meet AWT, almost, I would say, in my experience, 80 to 90% of the total nitrogen can be in the form of nitrate. So it's like liquid fertilizer. And removing the nitrate through denitrification is the process that you would use to get to remove that nitrate and put it back in the atmosphere as dinitrogen. The state of Florida Health Department did some of the, in my opinion, some of the most thorough and interesting research on how to design a septic tank system to include denitrification. And the bottom line was they came up with adding a carbon layer, like wood chips, for example, underneath the drain field in the water table in an anaerobic environment, because there are several things you need for denitrification: limited oxygen, nitrate as a food, and a carbon source to attract the microbes as well. And some of the media that they looked at were in the form of sawdust and wood chips that were effective. And so the one on the very left is called Nitrix. It's basically a clean wood chip that we've used, and it is really effective, it seems to be. But we've had good success with some other ones too. So we'll get into those. Next slide. Okay, so this first application is a nursery in North Florida that I worked with, and they fertilize the fields, as you can see through there. And that reactive nitrogen, nitrate in particular, is soluble, is seeping into the adjacent waterways. And all the ground kind of seeps and falls in that direction, and resulting in some really high nitrate concentrations. The soils are pretty porous, and there's really no stormwater BMPs. It's an older system. So what was done was simply to dig a trench along the edge of the farm, kind of where that trail is on the south side of all the vegetation. About 6 feet wide and 6 feet deep. Then it was backfilled with a mixture of 50% sawdust, which is the carbon material, and sand. And now you have this barrier, if you will, this wall that the nitrate is seeping through the water table. All the water is moving in that direction and seeping into these waterways. You can see that it was sampled with shallow wells on each side to measure the nitrate upstream and downstream of the denitrification wall. And this was monitored by the University of Florida, and University of Nevada also did some more additional work. Bottom line is the cost was about $50,000 for about 1,000 feet of this denitrification wall, if you will. So about a unit cost of $48 per linear foot. The removal efficiency that was measured by UF and University of Nevada was about 70% reduction in nitrate, or over 3,000 pounds per year. The system life, and this is the real critical thing, is because this carbon, this woody material, is in an anaerobic environment, it doesn't decay or oxidize as quickly. So the system life that is estimated by the University of Nevada, and I've seen this in the literature as well, is about 20 years. Could be as much as 50 in some literature I've seen. So it has an extremely long lifespan, and at that lifespan, that's really the critical thing in terms of its return on investment. It would be about 80 pounds per pound of nitrate removed. Okay. Second application, and this is really the opportunity for innovation. This technology is not really new, but I think that there's a lot of opportunities to get innovative with how you would use it or apply it. In this case, this is a large 500-acre community, golf course community. They receive reclaimed water that is not AWT currently in Sarasota County, and I think they're converting all their plants to AWT, by the way. But in the meantime, they receive reclaimed water into a storage pond, and that's all that pond is for. It's not a stormwater pond. It has berms on it. It just receives reclaimed water every day. As a result, that pond is really rich in nitrate, and you can tell by the color, but there's just not enough biology in that pond to uptake all that nitrate that's being put in. That water is then pumped out and dispersed into the golf course and the community throughout that area, and they're always finding algae in their pond. So what they decided to do, this was the community association, we were able to convince them that the best solution might be to try to get that nitrate at its source. Once it gets out in the environment, it will cause algae inlets, and that's how it's managed. And then they're fighting the algae. So what was done in this case were 2 gabion baskets were used. And if you're not familiar with that, these are the big metal baskets that they typically would put rock in and place along a drainage way for erosion control. But the basket was used as the container. We had 2 of them. We had a pervious membrane that we filled then the baskets with wood chips so that water could flow through the membrane. And then we had a couple of perforated pipes that were attached to a low pump. A solar pump would be fine as well. And these were these were sunk to the bottom of the pond. And the two systems were designed basically so that all the water in the pond would theoretically be recycled within a month. Next slide. So after the first year of operation, and I think these numbers are also conservative, the $20,000 I think is probably on the high end, but to be conservative, each basket then was about $10,000 per sample. We saw about a 55% reduction in total nitrogen, about a 77% reduction in nitrate, or about 3,000 pounds per year. Again, with a system life of 20 years, it works out to less than well, about 30 cents per pound for both nitrogen and nitrate removal. Next. And then the third application, kind of the last application for nitrogen I'll present is this is Lakewood Ranch, mainly in Manatee County. Lakewood Ranch set up a private irrigation utility when they initiated, 30 years ago, that is a non-potable utility providing groundwater, reclaimed water, and surface water as they are the sole provider of irrigation. It was done so that nobody could use potable, and there wouldn't be a lot of irrigation wells constructed. They basically controlled all of the irrigation water that way, which was pretty innovative, I think, to this day. The primary sources are alternative water sources. Surface water, we get pretty much probably 90% or so of the water, AWT water, from the city of Sarasota. Similarly, almost all of the water from the city of Bradenton, which is also AWT. We are currently negotiating with Sarasota County to get water from them, from the Bee Ridge plant that is being converted to AWT. But we also get water from Manatee County that does not meet AWT. And so in a cooperative funding grant with the Water Management District for building a reclaimed water pipeline and some storage, they suggested that we look at a passive nutrient reduction project as a pilot project. So I would like to say this was their idea, and I think it worked out really well. Lakewood Ranch and their utility was really interested in looking at this as well. Go to the next slide. And this is kind of the engineering drawing for it, but basically it's 4 cells. We built 4 cells that were separated by berms. And each received the same amount of reclaimed water through a drip irrigation system. There are under drains that then take the water into header structures that have a baffle in them that basically assure at that elevation baffle that the media is always underwater. It's like a bathtub. And the amount of outflow and inflow equalizes so that the thing remains in a kind of a steady state of inflow and outflow. And it's designed based on a contact time with the media. In these 4 cells, we use different kind of woody material. We use sawdust, we use just regular mulch, and then we used in the last 2 cells, we use the nitrics, the better wood chip material. The good news is we're seeing pretty much the same results with all of the media so far. And that's interesting because sawdust, by the way, is a waste product in Florida of unlimited supply and really no use, no beneficial use. So if we could, recycle that, help it with nitrate, that would be a great potential. Once it's treated in the cell, you go to the next slide. It overflows into a header trench that has biochar in it for phosphorus removal, and then flows into the storage pond to the north. That again is a storage pond exclusively for reclaimed water. It's not a stormwater pond, and there's a pumping station that then distributes the water from that pond to the community. So this pre-treatment system, if you will, that takes the non-AWT water from Manatee County, filters it through the media before it goes in the pond. We have, it's been up and running for over 2 years now, and we've been meeting AWT standards in that pond throughout. The cost of this project was about $750,000. That's the a typo there and an extra zero, but that was the cost of the project for the nitrogen component. And we're seeing between 66% removal in total nitrogen and 77% removal for nitrate. This slide did not get changed out from the last time because it's actually over 90% for nitrate, probably over 95%. A lot of the lab reports are coming back with the nitrate being undetectable. So it's been real efficient at removing nitrogen. The life cycle cost, again, based on 20-year life, was about $2.90 per nitrogen and $2.11 per pound of nitrate removal. Next slide. And the other thing that we did on this project that was interesting is Lakewood Ranch was interested as well. We had the local university had the ability to sequence the DNA of the bacteria in there to do that, to let us know what the diversity was and what are the species that are actually doing this work. And so for these 4 cells, you can see that the diversity of the microbes were between 550 and 905 different species of bacteria. Next slide. We also looked at what are the alpha species, and the top 3 were all denitrification type of bacteria. So it's not one type of bacteria that's doing the denitrification. It's several different kinds. We also found a bacteria that's able to, it's called Anamox. It's basically able to remove ammonia nitrogen in an anaerobic environment directly. And so at times we do get quite a bit of ammonia, unfortunately, in the reclaimed water from Manatee County. We really weren't designed to remove, to convert the ammonia, but there are some bacteria that have shown up that have been able to do that. We were getting about 50% removal of ammonia nitrogen when that did occur. That's not supposed to technically be happening, but there were some issues with the plant. Next slide. So to kind of summarize, again, $150 per pound of nitrogen removed and 1,000 pounds per year. These types of projects are extremely cost effective in meeting that. None of these projects sought or received funding for water quality. The one Lakewood Ranch project received proper funding from Southwest Florida Water Management District as a reclaimed water project. And other than that, all these projects, the other thing that's interesting is they were all done in the private sector, which I've always thought that's the real indicator of success. If you can get the private sector to do these types of projects, then that's telling you that they're probably pretty cost effective to do. Next slide. And then lastly on this is a project that I think is, it may have a permit by now, it's under permit, but this is about 3 miles of denitrification area. Again, edge of farm type of trench on a legacy citrus grove. And these are along some tributaries to the Peace River. So this is actually in the Charlotte Harbor watershed. But this is, and the beauty of this is really once you put these in, the land above them and backfill it is usable. You don't even know that the system is there. The key is to get them into the water table though, so they are, for the most part, anaerobic. Next. And so the application is really, it's limited. Anywhere that you have nitrate being generated, be it from agriculture, septic tanks, wastewater application that's not AWT, there are all kinds of ways to apply this media, provided you get in an anaerobic environment and there's nitrate present. So the sky is the limit on, I think, on how to apply this technology. The problem is it's not off the shelf. It's not something that is in a design manual that engineers and regulators can just take and input. But maybe that'll change in the next few years or as we move into trying to remove nitrogen more efficiently. Next slide. And then I wanted to just touch on phosphorus and a media that we've been testing for phosphorus uptake. It's, again, phosphorus is not as big an issue in a lot of this region, but it is in a lot of Florida and a lot of the United States. And by the way, these issues with nitrogen and phosphorus are not just limited to this region or the state of Florida or even the United States. It's everywhere in the world. So these technologies can be applied pretty much globally if these are issues. But this is a media, and it's basically a carbon-based media. Some people refer to it as biochar, and it's produced by heating organic matter with limited oxygen. So you're converting that media to carbon instead of ash, and it becomes extremely stable in that form as well. The other thing about it is, when you look at it under a microscope, it has an enormous amount of pores and surface area. So it holds microbes. We've tested a ton of this from all over the country because it's mainly being produced as a soil amendment. But when I talked to different manufacturers and told them we were looking at it for nutrient uptake, they were pretty much all interested in just sending us samples to look at. And the one thing I will say is that pretty much every media biochar product we tested absorbed a lot of water. So it's very absorbent. It could probably absorb. There's a lot of research on it now to absorb different types of pollutants, from pharmaceuticals to PFAS. The other thing I've noticed since getting into biochar, 5 or 6 years ago, is that when there's a controlled burn, that's essentially what's happening. Is at the base where the flames, at the base of the flames, there's very little oxygen, so it's charring the pine trees and the palmettos. And basically, you go out there, it's biochar that's out there. So it's kind of nature's way of putting charcoal or carbon back in the soil, and possibly why it regenerates so quickly. So on this, at the Lakewood Ranch site, this is the one project where we got a DEP Innovative Technology grant. This is currently underway. We've got a couple more months of sampling, but we're basically running the reclaimed water directly through several vessels filled with these charcoal pellets. They were developed, we developed these with the University of Florida. Dr. David Mazik up at the Department of Environmental Engineering has been is really unique to my view. He's a researcher that wants to figure out how to apply this in the real world. And so he's been, him and his group, he's got a couple companies up there that produce these. They've been using these charcoal or carbon pellets for to meet the clean energy emission standards for probably 6 or 7 years. And so he had all the dyes to do different densities and whatnot. We basically figure out a way to incorporate, with the University of Florida, by the way, in the research we did originally, the University of Florida, ironically, is probably the leading university in researching the use of biochar carbon material for wastewater treatment, moving nutrients from wastewater. So they're just right up the road. And so they were able to adapt the technology they already had for producing these pellets for meeting clean air emission standards to absorbing phosphorus. The University of Florida had done research using a feedstock for making biochar of sugar beet tailings. And those sugar beet tailings, when you char them, automatically formed, like calcium deposit, was magnesium deposits on all those surface areas. And that mineral, magnesium, is one of the minerals that absorbs phosphorus. So you cannot get rid of phosphorus through some kind of magic process that puts it back in the atmosphere. It's typically attached to minerals in soil. And so the magnesium oxide was used also as a binding media in the pellets, and it worked. And basically, that's the key: is the biochar has all these deposits of magnesium, the mineral magnesium oxide that attaches and binds up the phosphorus. The real key that we're looking at now in this process, it's effective in absorbing phosphorus. It's very low contact times, 20, 30 minutes. But the real key we're trying to figure out is what's the absorption capacity? How often does this need to be changed out? It's not like the woody material that'll last 20 years potentially. We need to understand how long this will last before we need to change out the pellet. The next slide. And so lastly, I just also wanted to touch on something I've kind of turned into an aspiring soil biologist of late in the last few years. and working with several composting operations, some of them commercial, to try to get healthy, beneficial biology into that compost. That's the real key. A lot of the compost that's out there commercially, frankly, it's not very good because it doesn't have the biology. That's really what you need, because that biology will do a lot of the work. And so we've been looking at this as really, this is the ultimate source control. There is pretty good science, soil science, on if you take a landscape that has been in existence for centuries and you scrape it clean, and all of that centuries of microbes and soil building, and then you dig a pond and compact 2 to 3, 4 feet on top of that, you've basically transitioned that landscape from back in time. You've converted it from a fungal dominated soil to a bacteria dominated soil. You've changed it from a more acidic pH to a more alkaline pH. You've also converted it to an environment that is more conducive for producing nitrate. And so the landscapes themselves may be, when we do that, may be generating more nitrate, which again can be soluble and get into our soils and water. So being able to use this, a good compost material with healthy biology would help reduce the amount of nitrate, and frankly, it would reduce the amount of water, fertilizers, herbicide, pesticide, fungicide, as well, that are all designed to kill the target microbe, but they kill everything. So we end up with soils that really don't have the ability to ward off diseases and reduce their immune system, kind of just like our own gut biology, I suppose. So with that, just want to make the acknowledgments of the folks that have been involved in these projects, and be glad to answer any questions that you might have.
Thank you for the presentation. Sure, Commissioner Cowan.
Thank you very much. Good to see you.
You too.
Just curious, those of us who have wastewater treatment facility, water reclamation facilities that we're expanding, we're incorporating AWT at this point. We have a time limit, was at the end of the decade. I think that if we're going to discharge this, anything that gets to surface waters, it has to be AWT, right? Something along those lines. I can't remember what that new rule is exactly, but I'm just curious, with this technique, could communities defer going to AWT? If you're getting it with this media to AWT standards before it's discharged to surface waters, would that possibly be an option? Have you got with the department on this as far as the rulemaking and things of that nature, Steve?
Well, the Department of Environmental Protection, I guess from their standpoint, for better or for worse, inherited the Department of Health Septic.
Right.
And the state had already figured out, a lot of that research was published on the Department of Health website. I don't think it got transferred when the program did. But that research that was done, I think at the request of the legislature, probably 15 years ago, really does lay out that there's a way to design septic tanks so that you're basically, it's an advanced wastewater treatment septic tank, basically, okay?
Mm-hmm.
And in some parts of Florida, I think it was in 2016, the legislature passed what was called the Florida Aquifer and Springs Protection Act. And so up in that area of the state, if you put in a new septic tank, you have to put in this denitrification system. I think there were some counties on the East Coast, Brevard County may have been one, that actually put that into an ordinance as well. So there's no reason why other counties and municipalities couldn't require the replacement, or if you do install any new septic tanks, that they meet that AWT standard, if you will. As far as the wastewater treatment plant, I think it's a good idea if you're upgrading it for capacity.
Might as well do it. Yeah.
You might as well do it anyway. But in the meantime, if you were to incentivize homeowner associations that receive reclaimed water in a pond to put in these denitrification systems, that would be a win-win for everybody in the meantime, because it's extremely cost effective, and it would it would reduce the amount of algae that they see in lakes as a result.
One more follow-up, Mr. Chairman. Sure. Now, you talked about reclaim and so forth, which is a great presentation, by the way. Stormwater, you know, I went through the same last 40 years as you have, you know, looking at all the different rulemaking, 1725 to the, you know, all the other rules we have for environmental stormwater treatment. What is the technique? I've been retired now for a dozen years. I haven't kept up on all the new standards, but what is the technique on treatment of stormwater that seems to be the most effective on removal of nutrients? It seemed like when I was 2010-ish, that time frame, that it was deep pool with enough planted material, submerged aquatic vegetation to take up the nutrients. Does that appear to be the most effective?
Well, it is somewhat effective. It will reduce nitrogen about 40%, but you reach a point of diminishing returns. That's all you're going to get, no matter how big or how deep the pond is. Jennifer and I served on the TAC back in 2010 that the state had to basically update the rules for that very issue.
Okay.
To increase nutrient reduction in our stormwater systems. So what has come of that is they reconvened. It got postponed for about a decade.
Mhm.
And it got rekindled last year. They reconvened the technical advisory committee, but I still don't think a rule has been passed. But more needs. Stormwater ponds are probably pretty good for phosphorus removal, but you're only going to get about 40% removal of nitrogen. So things like that we were looking at back in the rule were stormwater recycling, actually using that as an irrigation source, because that's a way to also take those nutrients and reapply them. The nutrients in stormwater ponds, in my experience, are much lower than reclaimed water and septic tanks and fertilizer, because you've got so much biology in those ponds to uptake it. But part of that biology is algae. So that's why there are all these, you know, there's not a community that's to fight erosion and algae in their stormwater ponds. So I don't know if that answered.
No, that's good. Just was curious as to how they're performing, because we didn't know back in the early, as you know, we didn't know in the early 80s what techniques were really going to be the most effective. Now we have some history. Thank you. Very good to see you. Thank you, Mr. Chairman.
Howard?
Very interesting presentation. I wanted to make sure I heard it correctly. We're looking at about 15 years of solid science on the nitrogen mitigation, septic tank drain fields and other conveyance. And along with that, do you believe the Department of Health is looking at changing rulemaking to carry that statewide?
And I don't think they are. But, you know, as the legislature changes over time, all this research that the Department of Health did 15 years ago, I don't know if the current legislature even is aware of that. But that research is, like I said, some of the best I've seen in my career. And it really should be carried forward, probably more than just for the springs. The thing on septic tanks is, or on-site wastewater disposal systems, I think is more fancy term, is that their effectiveness is, in my opinion, more based upon the local hydrogeology than anything else. So up in the springs where you have hilly and very porous soils, that soluble nitrate can move pretty quickly. In the flatwoods type of areas we have down in this area, from what I've seen from a lot of research that I did with the Gulf Coast Community Foundation on the playbook, we're getting a lot of natural denitrification here because of the hydrogeology. It gets into the water table, it moves very slow, so there's good residence time. That's a key. And if there's any organic matter in there, you will get the denitrification bacteria. But from the data that I saw, just not seeing really high nitrate concentrations in the waterways that receive just all blocks with subdivision that are septic tank. So it depends, but it doesn't hurt if when septic tanks are replaced, we were talking about this a little bit earlier, that they put in this. You think of the drain field as a cake layer. You have the sand that's converting ammonia into nitrate, and then below that, in an anaerobic environment, the water table, you have a layer of carbon material like wood chips that would attract the denitrification bacteria. And it could be probably really effective and maybe more cost effective. I think it probably will be more cost effective than trying to hook them up to the central sewer system. Thank you.
Great presentation, Steve. And to the gentleman earlier, I think you were referring to Senate Bill 64.
Yeah, I picture it.
Basically, you can't even discharge advanced wastewater treatment to surface water bodies after 2032, Senate Bill 64. Unless you can prove there's some sort of environmental benefit to that flow. So it's even beyond advanced water treatment. Steve, you have a slide on there where you showed the removal efficiency on a couple of projects, and you got TN and nitrate. Those of them you showed you remove more nitrate than TN. I'm just curious.
Yeah, the reason is that's what the denitrification bacteria is targeting. Okay, so that's going to be a higher percentage than the total nitrogen. Because you still have organic nitrogen and you still have basically organic nitrogen. In the Lakewood Ranch example, at times we had, because the treatment plant was not really nitrifying, we would have extended periods of ammonia nitrogen getting out into the system, but we weren't really designed to manage that. So we would get, so when you break down the nitrogen components, you're really knocking down nitrate. You're also knocking down total nitrogen, but percentage wise, not as great a percentage.
Yeah, I agree on the percentage, but the actual pounds, you showed removing more nitrate than TN, and nitrate is a component of the TN calculation. How can you remove
It's the
more?
same things. It's the same thing. Yeah, I mean, we can talk about it, I'll show you, but intuitively, it may not seem right, but it is.
Yeah, I'm trying to wrap my head around it.
You're really going after nitrate.
Scott Kilroy, Collins County. On your presentation, you noticed a mixture, or mentioned a mixture of sand and sawdust and the longevity of that. Being in the potting soil industry for 30 years, we blend potting soil every day. There are two main wood components: is pine bark or sawdust. Sawdust in our type of application in a container with potting soil in a nursery pot container, sawdust doesn't last as long as pine bark. You mentioned that the sawdust in a 50-50 mixture can have a lifespan up to 20 years. Is that because it's submerged within the water table? And there's very little oxygen there, and that's giving you your longevity in that backfill mixture?
Exactly. Otherwise, you're right, it'll oxidize very quickly, any wood material.
Yeah, recently, I mean, Highlands County, as of July 1st, the cost of putting in a septic tank and a drain field and on-site septic system has over doubled.
Yeah.
In our county because of some, whatever system that they're using to reduce the nitrogen output of those systems, what have you. So yeah, I was curious because I've got a friend that's been in that business for years and did a lot of that business in Highlands County, but is relocated and does a lot of business in Northport. And right now it's not a requirement in that area. So, you know, we're up on the ridge up in Highlands County. Just kind of curious. Seems like the closer to the coast, it would be mandatory there first. And more inland would be kind of the last in the order of the pecking.
Well, along the ridge, you're going to have nitrate that can move much more quickly, and
Because of the types of soil.
yeah, soil. I think that, and maybe Commissioner, does Charlotte County have a requirement on septic tanks of the different? It's got like a little pump in it or something.
Well, they have options on that.
Yeah.
Aerobic system.
Oh, yeah. So there are septic tanks designs that is required that add cost and quite a bit of cost. Adding a layer of organic media, woody material underneath the drain field when you're building new or replacing it probably wouldn't add a lot to the cost.
Yeah, my friend that's in that business, he has a sand or a fill pit in Highlands County. He's actually trucking fill from Highlands County to the Northport area daily. 20 trucks, because when he's digging those systems out, that on-site soil is not adequate. There's nothing in that area that's adequate for a drain field. So he has to bring it all the way from Highlands County down to Charlotte County or what have you daily. because the poor quality of the soil on site just will not work, will not pass.
Yeah, so it's really important to understand that the nitrogen cycle requires typically an anaerobic environment like we do with the drain field with clean sand to convert ammonia to nitrate. Then it requires an anaerobic environment to get the bacteria, the nitrification bacteria, convert the nitrate back into dinitrate. So you need both to complete the nitrogen cycle.
Got time for at least one more question, maybe two.
You talked about the barrier of the wall that was used in Holly nursery example.
Yeah.
Would that have any impact in reducing the flows of phosphorus as well?
They didn't sample that, but I wouldn't expect them to.
You wouldn't
I
expect
wouldn't expect it. We haven't really seen that the carbon in anaerobic reduces phosphorus. We have seen evidence though on the biochar that's designed for phosphorus uptake that it also has so far it looks like about a 25% reduction in nitrogen. So that might kind of be doing double duty, but that's not what it's intended. We just wanted to make sure that in reducing phosphorus, we weren't increasing nitrogen. So we did that as well.
Thank you.
What happens with the material? What's the cause of the degradation of your substrate material that gives you the 20-year life? And at the end of the life, what do you do with that material? Does it have to be disposed of somehow?
Well, okay, so for the weed material, I think it's, the microbes are eating, they love the nutrients. The bacteria is the most nutrient dense organism on the planet, right? They're going after the nitrate. But the other source is carbon. So they're also consuming some of the carbon, just not at as fast a rate. So what's going to happen over time, like on the Gabion baskets or in the bottom of the lake, I suspect what's going to happen when we know it's over, those Gabion baskets are going to float to the top because the carbon wood chips will have been consumed by the microbe, but it takes a long time. So the biochar that absorbs the phosphorus, that needs to be maybe swapped out more frequently, much more frequently. The question is, what do you do with that? And there are some, I've talked to some landscape people that are interested in marketing that waste project because it will be already inoculated with phosphorus that's bound up. And then if you put it in the soil, the microbes then can get to that phosphorus and make it bioavailable to plants. It's bound, so it's not in the form of PO4 or the phosphate. So the recycling of the biochar material is an interesting, and I think that it could have value in terms of being used as soil.
I want to ask if there's any questions from any online participants.
Yes, Mr. Chair. This is James Satcher. I was just going to request if someone could send a link to this portion of the presentation and then just the contact information for Stephen so I can follow up with some of my staff in Manatee County.
Yes, we would be happy to do that. And Steve, I just don't know if you have 1 or 2 more minutes just to talk about the fact that you've done analyses to isolate where the nutrient hotspots are in different counties. And sometimes those are old package plants or trailer parks, and that you've been able to target these strategies to address those nutrient hotspots. Could you just give us like a brief explanation?
Effort we worked on with the Gulf Coast Community Foundation to update the playbook. We looked at about 70 long-term water quality monitoring sites. Some of them had flow too, so we could look at loading. And what we were really interested in looking at on all those sites was how much of the nitrogen on average is in the form of nitrate. Okay. We manage total nitrogen, by rule in the state. But if you look at a lot of sites, honestly, I don't see much difference in the total nitrogen between an urbanized area and a natural area. It's really hard to discern total nitrogen variances. I mean, if there's something really going on, you'll see high nitrogen, I grant that. But what we saw was there seemed to be a real correlation between the amount of anthropogenic changes in the watershed, be it, development and wastewater and all that, and the percentage of that nitrogen that is in the form of nitrate, the bioavailable stuff that causes algae blooms. And so when we started to look then where these were occurring, it looked like, believe it or not, because I think this falls through a lot of cracks in nutrient management, is most of the sites were packaged wastewater plants where they put a pond right next to a waterway. Why? Because they're seeping nitrate 24/7. And so we would see in a real short, we would see really nice low nitrite concentrations upstream, but just where that, and then we had one right downstream. But time and time again, we saw this where there's a pond of a packaged plant that's basically, that's how they're getting rid of it. They're ponds, but they're really just seeping nitrate 24/7, and it's showing up in the waterway. It's just groundwater seepage, right? Because the drainage way could be 20 feet deep, and they're stacking up these ponds as high as they can, get them to get enough head to seep the water through. So there would, from a cost-effective standpoint, if you really wanted to try to reduce nitrogen and particularly nitrate, I would focus hooking those folks up to central sewer once it's AWT, and or putting a denitrification barrier between that pond and the canal so that that water's always seeping through carbon material anaerobically that will denitrify. So then we're, we got this, and it was mainly done in the Sarasota County region where they had all this water quality data, but I think there's a lot in Charlotte Harbor as well that would be interesting to look at in that same context. But there was a definite trend looking at 70 sites that the more we change the watersheds, the more they seem to generate nitrogen as a form of nitrogen.
I want to thank you for this presentation and all the discussion that it sparked. It was a wonderful presentation and just great to focus on the effects of biology and natural systems for addressing some of the challenges. And it's a great transition into our next presentation